The next heading is image formation by concave mirror. We are going to learn the sixth case. We are going to learn sixth case. All 5 cases I have already discussed. The position of the object. As we change the position of the object, we get different cases. The 5 cases I have already discussed. If you don't remember or if you have any doubt, you can watch the recorded class. But I don't want to repeat the previous class now. So the sixth case is object is placed between pole and focus. Let me explain the diagram. After that you can ask me doubt. I will clarify all your doubt. Don't worry. Okay. But let me complete the theory. Let me complete the diagram. So here what we are doing is the object, for example a candle. An object is placed between pole and focus of a concave mirror. The diagram is this, but I would like to explain step by step. Okay, explain by step by step. I will show this diagram. It is taken from textbook. So this is the last case. All of you please listen. Let me explain step by step. So we have a concave mirror like this. Understood? Concave mirror, right side there is a coating. This is said to be concave mirror. In the right side there is a coating. Left side a reflecting surface. So here you know that the basic things you are familiar. This is said to be the principal axis, and this point is said to be pole. This is said to be pole, and here there will be center of curvature. Here there is center of curvature C. What do you mean by center of curvature? Because this mirror, if we extend this mirror, we get a sphere. Understood? We get a sphere. That sphere will have a center. That is said to be center of curvature. We studied that. I am repeating actually. And there is another one, focus. It is defined as the middle point. The focus is defined as the midpoint of CP. The midpoint of CP is said to be focus. So here what we are doing, an object, for example a candle is there, which is placed very nearer to the mirror. Very nearer to the mirror, meaning that the candle is placed between pole and focus. Somewhere here. AB is the candle. AB is the object which is placed very nearer to the mirror. What happens? Before drawing the diagram, you know that it will be enlarged image. How? I will tell you. Before that, we know that the fact. 1 minute. Look at this diagram. You can understand. Before drawing the ray diagram, you can understand what kind of image you will get. The first one is the concave mirror, right? This is the concave mirror. If the object is placed very nearer to the mirror, what do you expect? For example, this hand is very nearer to the mirror, meaning that it is between the pole and focus. The hand is now placed between pole and focus. I mean very nearer. If the object is placed very nearer to the concave mirror, you will get an enlarged image, but that enlarged image is not inverted, it is erect. But the other images you can see they are inverted, like trees. Look at this diagram, you can see the trees are smaller and inverted, but the nearby object will not be inverted, it will be enlarged and not inverted, erect. So we know the property of image even without drawing the ray diagram. But by drawing ray diagram, I will explain the nature of the image. So you please listen, all of you please listen. Let me complete the diagram. After that you can ask me doubt. Okay, let me complete this diagram. So let it be hand. Okay, this AB be the hand or candle placed very nearer to the concave mirror. Let us see what happens to the image. We studied in the previous class that here what we are doing is in different ways we can draw the ray diagram. but you must draw the same diagram given in textbook. You must draw the same diagram given in the textbook. If you draw any other kind of diagram, you will not get mark. Actually, in different ways you can draw the diagram. You will be getting same image, but whatever given in textbook, that diagram you have to draw. So to find image of A, what you have to do is you have to draw one ray starting from A. From A you see that there are plenty of rays. Understood? Candle. A is the top position of the candle. From A there are plenty of rays. There are plenty of rays. I will clarify all your doubt, Usma, Joshida, everyone, but let me complete this. After that you can ask me doubt. Okay, that is the right way. So there are plenty of rays starting from A. You have to choose any of the two rays. You have to choose any of the two rays starting from A. Let me select one ray moving towards pole. The right side is pole. So let me draw one ray moving towards pole like this. A ray coming out of A. It will be reflected like this. We know that this angle will be equal to this angle. I have already discussed this. We studied 4 rules in the previous classes. We studied 4 rules. Any ray meeting at the pole will be reflected like this, in such a way that this upper angle equal to lower angle. These two angles will be equal. We studied it as a rule actually. So a ray coming out of A meet the pole P, it will be reflected like this, so that these two angles are equal. And I want one more ray starting from A. The one ray is, let me draw a normal ray. Normal means it is perpendicular to the mirror. If you don't see this diagram, you can zoom it. You can zoom it using 2 fingers. Using 2 fingers, you can zoom it. Okay, so you can do it. Even if you use laptop or mobile, you can zoom it. So so you can please zoom it if you don't see this diagram properly. So let me draw a ray emerging out of A, normal to the mirror. This ray is normal or perpendicular to the mirror, right? Meaning that this is 90. Can you see that? This is 90. Understood? If you don't see, you just zoom it. So we studied it as a separate property in the previous class. Any ray normal to the mirror, whether it is concave or convex, any ray normal or perpendicular to the mirror, it will be returned through the same path. It will be returned through the same path. It will be returned through the same path. Goes like this. Understood? Just like if you throw a ball like this, normal. If you throw a ball, the ball will be rebounded through the same path, like that. A normal ray rebounded through the same path, and all the normal ray will be passing through the center of curvature. It is also a fact. All the normal ray rebounding through the same path, passing through the center of curvature. Now I have got 2 reflected rays. I have got 2 reflected rays coming out of A. This is one of the reflected ray coming out of A. It passed. It was normal, but rebounded through the same path, going like this. And another reflected ray going like this. The 2 reflected rays I have highlighted. So the point of intersection of 2 reflected ray will be image of A dash. These are the 2 reflected rays starting from A. Understood? The reflected ray produced by A are these 2 rays. Will they meet in the left side? Will they meet in the left side? No. If you extend backward, if you extend, these 2 rays will never meet, because the gap is increasing. The gap between the rays are increasing. These 2 will never meet. They will meet only if I extend backwards. If I extend backwards, then only it will meet. In the left side, it will never meet, but it will meet only if I extend backward, behind the mirror. If I extend the reflected rays behind the mirror towards behind the mirror, it will be meeting, but in the left side it will never meet. So this will be A dash, image of A, meaning that why A dash, the image is a position is A dash, I will tell you. Suppose this is my eye, okay, this is my eye, this is my eye, I am watching, this is my eye, okay, I am watching. When I watch, I can see that two rays are coming like this. This is my eye, okay, imagine like that, this is my eye. When I watch this, I feel that two rays are coming towards my eye. So what I feel that these two light rays are originating from A dash. Understood? Look at this diagram carefully. My brain tell me, okay, my brain convince me that these two rays are originating from A dash. Understood? Look at this. Understood? This rays look like emerging out of A dash. This rays also appear to be emerging out of A dash. So my brain convinced me that these two rays are actually coming out of A dash. It is virtual. Virtual means we feel that there is an image here, but in fact there is no, I mean, if I keep a screen, if I keep a wide screen here, I cannot see anything, because there is a coating here. Definitely I will interact with you, but let me complete this. There is a coating in the right side. There is a coating in the right side. The right side is completely dark. Right side is completely dark. But if I watch from this side, I feel that these rays are coming from A dash. So I think that there is an image here. But if I keep a wide screen, this A dash, the image will not be available on the wide screen. So I think that the top of the candle, the image of the top of the candle is here. If you keep a vertical object, the image will also be vertical. If you keep a vertical object, the image will also be vertical. So A dash B dash will be the image. So I feel that an enlarged image, a small candle is placed nearer to the mirror. I feel that there is a much larger candle standing here, but if I keep a screen here, the image will not be available on the screen. So this will be the case. So we get an enlarged and erect image. We get enlarged and erect image in this case. So I hope you have understood. I repeated many times, but you can ask me doubts. Samruddhi, Joshida, Usma, Lina, Nishid, if you are 100% clear, if you are 100% clear, you can raise your hand. If you have any doubt, please ask right now. Samruddhi, Joshida, Usma, all of you clear? Nishid?
Yes, sir.
Lina, you understood. So, okay, the diagram is already copied from the textbook, the same diagram, okay. Okay, you may mark some point P. P is already marked. This E is not important point. Okay. So anyway, this is taken from textbook. The same thing, whatever I have drawn, the same thing is obtained here. So you please draw this diagram, or you may draw it later. No problem. You have to use the scale and pencil. Okay. The scale and pencil is required. Otherwise you will not get a good diagram. So you can see that we get an enlarged image here. Let me write the properties of image first. Let me write the properties of image. The property of image is, the first property is, the image is enlarged. And before that, the image is real or virtual. It is virtual image. The image is virtual. It means that if I put a wide screen, I cannot get this image on the screen. This side is completely dark region. There is a coating here. This region is completely dark. But if I watch from this side, I feel that there is a big candle standing here. Virtual image. The second property is virtual and it is erect image. Erect means it is not inverted image. Third one is enlarged, magnified, enlarged or magnified image. Then fourth, image behind the mirror, image position behind the mirror. So all properties are written. So you please draw this diagram, or if you want to draw later, no problem, but you must draw the diagram on your notebook. You have to send me the diagram after the class. If you have drawn everything, if you have finished, please raise your hand. If you have finished, please raise your hand. Samrde, Joshida, Usma, finished. All of you have finished. Okay. Just a minute. I will come back within 2 minutes. I will come back within 2 minutes. Till that time, you please read all the 6 cases. Okay. I will come back within 2 minutes. So, okay. So, all 6 cases are over. So, the concave mirror, the 6 cases I discussed. The next is image formation by convex mirror. Only 2 cases are there. Image formation. Actually, this part I have already discussed. The image formation by convex mirror. This is a simple diagram I will discuss. All of you please listen. Image formation by convex mirror. Look at this diagram. You can see a convex mirror here. It's a convex mirror. I am standing in the, I will be always standing in the left side. Bulging towards me. Understood? Bulging towards me. It is said to be convex mirror. Right side there is a coating. So if the object, the case 1, only 2 cases are there here. Only 2 cases. Case 1. Case 1, object at infinity. Object at infinity. Actually this part I have already discussed. Object at infinity means there is a tree. Okay, there is a tree a few kilometers away from the mirror. Think like that. There is a tree which is a few kilometers away from the mirror. A few kilometers means we can say it is at infinity. We can say like that. It is at infinity. What do you expect? What do you expect? I will tell you. I will tell you. What do you expect? 1 minute. Yes. Look here. Now I am talking about the second kind of mirror. Understood? I am talking about the second type of mirror, which is convex mirror. Bulging towards me, right? It is, if you look at the diagram, you can understand. Bulging towards me. So if the object is, consider there is a tree which is a few kilometers away from the mirror. You can see it will not be inverted. Wherever be the object, it will never be inverted. It will be erect. But if the object is too far away from this mirror, the image is extremely small, look like a point. Understood? You look at the trees inside the mirror, image of the trees. If the tree is much larger, far away from the mirror, the image of that tree is extremely small, look like a point. Understood? The tree will be look like a point. Okay, just for your information. So I will explain with the help of ray diagrams. I will explain with the help of ray diagram. Here we have a tree AB. AB is the tree. The rays coming from the tree will be parallel. Understood? The rays, all the rays coming out of AB will be parallel to the principal axis. Understood? I hope you have understood. For example, sun. The sun is at infinity, right? Concave mirror is kept like this. A sun is at infinity. All the sun rays will be coming like a parallel rays. You studied it as a rule. Please listen, all of you please listen. Consider one of the parallel rays from the object. This after reflection we studied it as the rule 1, first rule. If you don't remember, you may watch the recorded class. Any parallel ray, it will be reflected in such a way that the rays will be reflected in such a way that the extension, if we extend the reflector ray, it will be meeting at the focus. Focus will be in the other right side. Center of curvature is also in the right side. This is because of the fact that the sphere will be like this. So of course center will be in the right side. The focus will be the middle point of PC, hence focus is also in the right side. You have studied that. So this is the rule we studied. Any parallel ray, it will be reflected. That ray cannot go inside the mirror, okay? It cannot go right side. It will be reflected in such a way that if we extend it, it will be reaching focus. So if you draw any such parallel rays, you can see the same property. Another ray coming out of the object, it will be reflected, but if we extend it, it will be meeting at the focus. So all the rays reflected and extended meeting at the focus. So I am watching from this side. Suppose I am standing here, I am watching. These rays enter my eye. Understood? These reflected rays enter my eye. I feel that these rays are originating from F. Understood? We feel that these reflected rays actually coming out of F. In fact, it is not from F, but our brain convinces us that these rays are actually emerging from F. Understood? So there is a point-like image obtained at focus. A point-like object. There is a big tree here, but we get a point-like tree, a smaller one. A point-like image at the focus. So my conclusion is, the case one is, if the object is at infinity, what happens? What are the properties of image? If the object is at infinity, the image is at F. Image at exactly at the focus. And the size of the image is, it is a point-like object. So we say that highly diminished. That is a formal way we write. Highly diminished. We cannot say anything about inverted, understood, erect. We cannot say anything about that. It is actually a virtual image. Any image obtained in the right side, any image obtained in the right side, it will be virtual. If I keep a screen, I cannot see, I will not get the image. I mean, this image is in the coating side. There is a coating in the right side. If any object or any image obtained in the coating side, it is virtual. So I hope you have understood. If you are 100% clear, then raise your hand. 100% clear. And if you don't understand, you please ask me. Lina, you understood, Lina? Joshida?
Yes, sir.
Nishit, clear? Nishit?
Yes, sir, clear.
Okay. So, finished the case one, object at infinity. So the next is you finish, right? Case 2. I will explain with the help of this diagram, okay? Case 2. Case 2, the object is not at infinity. Only two cases. Case 1 is object at infinity. Case 2 is object is not at infinity. Not at infinity. A little far away, maybe nearer or some distance away from the mirror, but not at infinity. Not at infinity. This is case 2. I don't want to draw a separate diagram. I will explain everything with respect to this diagram. Case 2, there is a tree. There is a tray nearer to the convex mirror. You know that you will get a smaller tree. the image will be a smaller erect image. So there is a tray which is placed nearer to the mirror. The object is not at infinity. So first AB is the tree. Okay, AB is the tree object. The two rays I have to consider a ray coming like this, parallel, a ray going like this, parallel to the principal axis. We studied the rule that it will be reflected like this. It will be reflected like this in such a way that if I extend backward, it will be meeting at focus. It is rule 1. Okay, parallel ray will be reflected. If I extend the reflected ray, it will be meeting at focus. Understood? So this is the reflected ray. Okay, understood? This is the extension. Okay, this is just an extension. Extension meeting at focus. Now I want to draw another ray. You must draw the same diagram. In different ways we can form the ray diagram. One ray can be towards pole, no problem. But in exam you have to draw the same diagram. Let me draw another diagram. Another ray is coming out of A like this. There is another ray emerging from A. There are plenty of rays coming out of A. This is another ray from A. Let me draw it as normal to the mirror. I mean 90 degree. Understood? This ray is perpendicular to the mirror. I have already discussed that any ray perpendicular to the mirror will be retraces the same path or rebound through the same path, and the extension will be meeting at the center of curvature. The normal ray after reflection, it will be meeting at the center of curvature. Here extension will reach the center of curvature. Understood? Because in the left side these two reflected rays never meet. I will give tick mark. This reflected ray and this reflected ray, these two will never meet in the left side because their gap is increasing. The gap is increasing. Understood? This is, suppose this is my eye. Suppose this is my eye. I am watching. I feel that this ray and this ray emerging from this point. Can you see the intersection A dash here? Can you see a point A dash here? If I am watching, this is my eye, this reflected ray, the tick mark, okay, this reflected ray and this reflected ray, both the rays are emerging from A dash. Our brains says to us that these two reflected rays are originating from A dash, from this point. So here we get any virtual image. Understood? Understood? Goes like this. This one goes like this. So both the reflected rays are starting from A dash. Our brain says to us like that. So draw a vertical at that point, we get A dash B dash. We get a smaller size image A dash B dash. So a larger tray look like a smaller tree. It is a erect image also. It is erect image also. So you please draw the diagram. I hope you have understood. If you don't understand, you can tell me. You please draw this diagram. So let me write the properties of images. Let me write the properties of images. So there is a larger tree, not at infinity. If you watch through the convex mirror, you will get a smaller tree. The image will be a smaller one, but it will be erect. The properties of images is, we get a virtual image. Why virtual image? Virtual image is the image in the right side, coating side. The image is in the coating side. Virtual, the image will not be obtained in the white screen. The second one is it is erect image. Third one is a diminished image, smaller, diminished. And fourth property is image is obtained between pole and focus. The image position is between pole and focus. So all properties are written. So you please write down. If you are 100% clear, you can raise your hand. Nishid, Lina understood. Usma clear? Okay, understood. And Lina, you have already understood. Joshida, do you have any doubt, Joshida?
No, sir.
Nishit, everyone okay. So you have to send me the photo, okay? You have to take the photo of this diagram and send to me through WhatsApp. So all the diagrams I explained, concave mirror and convex mirror. Then next we are going to learn an important formula, which is mirror formula. The proof is not there in our syllabus. Its proof is there in 12th standard physics. In 12th standard physics, its proof is given, but in 10th standard the proof is not there. I will explain one important formula. Memorize that formula without any proof. So we have a mirror. It may be concave or convex. Okay, we have a mirror, can be concave or convex, whatever may be. The object, if you keep an object somewhere, this is not the exact diagram. I will delete it. Okay, I will delete it. Suppose if you keep an object, for example a candle, AB, somewhere in front of a mirror. Mirror may be concave or convex. You will get the image, right? You will get the image. That depends on the position. Sometimes you may be getting the image inverted, or sometimes you may be getting the image here, or sometimes you may be getting image here. The position of the image changes if we change the position. There are different cases I explained. So the image position varies if you change the position of the object. For the time being, suppose the image is here. This is not the exact diagram. Suppose the image is A dash B dash. So there are five important terms you have to understand. There is a very important formula. Let me explain the important terms. The first one is U. U is, there are 5 important letters. The first one is, you listen carefully, U is the distance between pole and object. Pole and object. It is always denoted by U. If the figure is like this, the pole or mirror and object. U is the distance between the mirror and the object. So as per this diagram, what is U? As per this diagram, U, I will show you. The U will be like this. U is the distance like this. This will be U. What do you mean by U? U is the distance between the object and the pole. All the horizontal distance are measured from pole. The distance from the mirror always measured from pole. So U is the what? It is the distance between the pole and object. I will clarify all your doubt, but listen carefully. U is a distance. Okay, I marked in the diagram. Okay. And there is another term V. V is the distance. There are 5 important letters. V is the distance between pole and image. Pole and image. If the diagram is like this, I'm not saying the diagram always look the image position changes actually. The position of the image will be changed as the position of the object changes. Okay, just for your understanding. Okay, let me draw like this. So V is the distance between what? Distance between pole and image. A dash B dash is the image, right? So V will be this distance. V is the distance between pole and image. All the horizontal distance are measured with respect to pole. So all of you clear? U and V both are okay? All of you clear? U and V. Samriddhi, Lina, Usma, Nishit, U and V is clear? The terms, okay.
Yes, sir.
The next one is already familiar to you. It is what? It is the focal length. Focal length we have already studied, but let me explain once again. F is the focal length. F is said to be the focal length. Focal length is the distance between, I have marked in the diagram, pole and focus. The distance between pole and focus, that is said to be focal length. Let me write like this, okay? PF, distance between pole and focus, that is said to be focal length. So UVF, 3 letters I explained, and 2 more letters are there. The size of the object or height of the object. H is the height of the object. Height of the object or size of the object. So height of the object I will show you in the diagram H. AB will have a height, right? The candle or tree will have a height, that is H. And one more letter is, the last letter is H dash. H dash is the height or size of the image. So these 5 letters you have to understand. H dash, height of the image is denoted by H dash. So the 5 letters I explained. U is the distance between the object and pole. V is the distance between the image and pole. F is the distance between the focus and pole. H is the height of the object. H dash is the height of the image. So all these 5 letters are clear to you? All these 5 letters are clear? Joshida, Nishit, Usma, please respond. Samruddhi. Okay. Now listen. When you write U, V, F, H and H dash, you must consider the sign. If you don't consider the sign, you will get a wrong answer. So please remember, the sign is required. The sign convention I will discuss. It's a very simple thing, the sign convention. Consider this is pole. Pole, you know, pole. All the horizontal distance are measured from pole, right? The distance towards right side, all the horizontal distance towards right side is considered as positive. I don't want to write it in sentence, I want to draw in diagram. All the horizontal distance towards towards the right side of pole, all the horizontal distance towards right side of pole is taken as positive, and all the horizontal distance towards left side is taken as negative. I will explain, don't worry, I will explain that. All the horizontal distance which is lying in the left side of pole is negative. You have already studied right side positive, left side negative. All the distance are measured from pole, that is why. So if the diagram is like this, the U will be negative. U will be always negative actually, because we keep the object always in the left side, that is the reason. So the U is the distance, the horizontal distance U is towards left side of pole. U towards left side of pole. Hence U is always negative. And if the diagram is like this, I am not saying that image will be always in the right side. If the diagram is like this, the V will be positive, because the horizontal distance V towards right side of pole. If the horizontal distance in the right side of pole is positive. But remember, if the image is obtained in the left side, then V will be negative. So if the diagram is like this, V is positive, all the horizontal distance towards right is positive. So F will be negative. So F will be, as per this diagram, F will be negative because the focal length will be towards left side, from pole towards left. So the sign convention is clear. The horizontal distance, all of you clear?
Yes, sir.
Okay. And one more thing is regarding the sign of H and H dash. So UVF, the sign of UVF as per this diagram, okay, and the sign of H and H dash I am going to discuss. Let it be the principal axis. Let it be the principal axis. Pole, the position of pole I don't want to explain. For the sign of the height H and H dash, we don't look at the pole. We will consider only the principal axis. The height above principal axis. The height above principal axis is taken as positive. All the height above principal axis is taken as positive. So as per this diagram, this H will be positive. If the diagram is like this, H is positive because this height is above principal axis. So any height above principal axis taken as positive. But any height below principal axis, wherever may be the position, if the height is below principal axis, regarding height, I am talking about height, then the height is negative. For example, if you get an image A dash B dash, if you get the image A dash B dash like this, in that case H dash is taken as negative because the height is below principal axis. If the height is below principal axis, it is negative. If the height is above principal axis, positive. Clear? So these two are very, very important. The sign convention is very, very important. So the first one is for horizontal distances. First one is for horizontal distances. Horizontal distances. The second sign convention is for height. Vertical distances. Height for vertical distances. For H and H dash. So these two sign conventions are okay. Clear? All of you clear? These two sign conventions are okay. Please respond. Lina, Usma, Nishit.
Yes, sir.
Okay. So let me write two important formulas. I told you that its exact proof is there in 12th standard. In 10th standard, proof is not there. Only thing, you just memorize the formula. So mirror formula is 1 by U plus 1 by V equal to 1 by F. This is the mirror formula. There is one more formula I will write here. There is no space. The mirror formula is 1 by U plus 1 by V equal to 1 by F. If you focal length generally given in the question, will be given in the question. So if you give the position of the object, we can easily find the position of the image using this formula. This is said to be the mirror formula. What is this? This is said to be mirror formula. There is one more formula. Let me write here. There is no space. Magnification. Let me write one more formula. Magnification, denoted by the letter M. It is defined as the size of the image by the size of the object. Size of the image divided by size of the object. For example, magnification, say 2. What is the actual meaning of that? Magnification 2 means the image is 2 times the size of the object. Magnification 100. Magnification 100. What does it mean? The image size is 100 times the object size. So magnification is important, especially in the case of lenses, microscopes. The magnification is important. How much times larger than the object is the image? That is magnification. It is image size by object size. We have another formula. Proof is beyond our syllabus. Proof is beyond our syllabus. Memorize the formula only. We have another formula for magnification, minus V by U. So the second formula for magnification, we get a complete idea about the image, whether it is enlarged, whether it is inverted, like that. So all of you please write down. If you have finished, please raise your hand. If you have finished, please raise your hand. Samriddhi, Nishit, Usma, all of you clear? Lina,
Yes, sir.
okay. I will discuss one question. I will discuss one question, and remember, you please write one note here. One note here. U is always negative. You can understand the reason. You see, the mirror will be placed somewhere. We keep the object in the left side. Okay. All the problems will be like that. We will do the problems in that way. The object will be placed in the left side, so the horizontal distance u will be always negative. Whether it is concave or convex, we will be placing the object in the left hand side, so the horizontal distance u will be negative. And another point is f will be positive in the case of convex mirror. F is positive in the case of convex mirror. Convex, later we will learn convex lens. For convex mirror as well as convex lens, f will be positive. What is the reason why f is positive? I will tell you. The convex mirror look like this. The convex mirror look like this. This is pole. This is pole. Center of curvature will be here. The focus will be here. The focus lies in the right side. Understood? In the case of convex mirror, the focus point, the point focus, lie in the right side of pole. So this horizontal distance will be positive. So the same feature for lens also. We will learn lens later. So for convex mirror as well as convex lens, focal length is positive. Please memorize that. Okay, please memorize that. Memorize. Okay. And f negative for concave mirror. Concave mirror. You can zoom if you don't see that. Yes, if you look at this picture, you can understand that why is focal length is negative. In the case of concave mirror, this horizontal distance f towards left side of pole. This is what kind of mirror? This is concave mirror. The focal length, the horizontal distance towards left. So for concave mirror or concave lens, you will learn lens later. For concave, focal length negative. You have to memorize it, never forget it. Useful in multiple choice question. For convex, focal length positive. Concave, focal length negative. In all problems, u is taken as negative. So you please write down this one, these 3 points. If you have written, please raise your hand. If you don't understand anything, please ask. Samriddhi, Nishit, Usma, you don't have any doubt?
No, sir.
Lina, understood. Okay, Joshida, clear. Let me discuss one question. I will discuss more problems in the next class. Okay. This is taken from textbook. Okay. Taken from textbook. Let me discuss this problem. I will read it. I will read it. A convex mirror used for rear view of an automobile has a radius of curvature 3 meter. If a bus is located 5 meter from the mirror, find the position, nature and size of the image. The diagram is not necessary, but if you don't understand the question, it is better if you draw the diagram. But diagram, in order to solve this question, diagram is not necessary. We have a convex mirror, right? We have a convex mirror. Let me draw the diagram. Remember, the diagram is not necessary. If you remember the formula, you can do it. What is this? This is pole. Okay, pole. The center of curvature will be here, right? Because the center of the sphere will be in the right side. That is the reason. And the focus will be the middle point. Okay. So the question says that there is a convex mirror, radius of curvature. The radius of curvature is what? It is the radius of the sphere, right? The radius of the sphere, this distance. Understood? I explained that PC, the sphere will have a radius, right? That is radius of curvature. The radius of curvature is 5. It will be 5, sorry, not 5, 3, sorry. Radius of curvature is 3 meter. Will it be plus 3 meter or minus 3 meter? Nishit, you please tell me, radius of curvature, is it plus 3 meter or minus 3 meter? You please tell me.
Sir, +3.
Plus 3 meter, because the radius, the horizontal distance towards right side of pole. You know that the focal length will be this much, the middle point, right? The focal length is the middle point. F will be the half of the radius. We studied already, not first time, we studied already. I have again and again I told you, F is the middle point of PC. Hence the focus will be the focal length will be the half of radius. 3 by 2 plus itself. It's convex. 3 by 2 meter. Till this step all of you clear? Till this step F equal to plus 3 by 2. All of you clear?
Yes.
So all of you clear? I think you understood that. The next step is, anything else given? Yes, there is a bus. There is a bus some away away from the mirror. I don't want to draw a beautiful diagram. This is bus. Okay, a bus is situated how far away from the mirror? 5 meter away from the mirror, right? 5 meter away from the mirror. The bus is located 5 meter away from the mirror. That is actually u, right? That distance is said to be u. The bus is located 5 meter away from the mirror. U is always taken as negative, so u equal to minus 5 meter. If you forget to write negative side, the entire solution will be wrong. Suppose it is a 3-mark question, you will be getting some half mark or 1 mark, I think so, because from the beginning you made a mistake. The sign is very, very important. Okay, u is negative. We have to find out v. V is actually the image position. We get a small bus, image of the bus will be somewhere here or here, I don't know. The image position we have to find out, as well as all the properties of image also I want to find out. Whether it is inverted, whether it is smaller or enlarged, all the details I want. So till this step all of you clear? Lina, Usma, Joshida, Samruddhi, all of you clear till this step?
Yes, sir.
Okay, so you understood. So yes, which formula to be used for finding the position of the image? Position of the image is v, right? This is a rough diagram. The position of the image is v. Distance between the pole and the image is said to be v. We can find out v by using the mirror formula, 1 by u plus 1 by v equal to 1 by f. The mirror formula to be used, v, let me rearrange it. 1 by v equal to 1 by u can be taken to the other side, 1 by f minus 1 by u. Better write this step. I want v. 1 by f. What is f? 3 by 2. F is 3 by 2. Minus 1 by u. U is given as minus 5. If you don't understand, you can ask me, but let me complete the solution. Let me complete it. 1 by 3 by 2 becomes 2 by 3. By taking reciprocal, 1 by 3 by 2 becomes 2 by 3. Here minus of minus, it becomes plus 1 by 5. You know how to add them. Do the cross multiplication. 2 into 5, 10. If you don't understand any step, you can ask me. 1 into 3, 3. 3 into 5, 15. We got 13 by 15. This is not v, this is actually 1 by v. Left hand side is 1 by v. But I want v. Just take the reciprocal. 1 by v equal to this. What is v? V is obtained by taking reciprocal. 15 by 13 meter. You need not do the division. So the position I got. The position, I mean 1 point something, right? 15 by 13 will be 1 point something. 1 point something will be somewhere here. Actually, the ray diagram we have already studied. The image will be somewhere here. We have already studied that the image will be between pole and focus. We have already studied. So V is 15 by 13. I mean 1 point something meter away from pole V. So anyway, the position I got. The position of the image is 15 by 30 meter. The plus sign of V suggests that. The plus sign, right? The plus sign suggests that the V towards right. Plus sign indicate that the V, the horizontal distance V is positive. I mean the image in the right side. Till this step, all of you clear? Till this step? Lina?
Yes.
Benedict, sorry, not Benedict. Nishit, Joshida, all of you clear?
Yes, sir.
Let me complete the solution. So I did not get the complete information about the image. I got only the position of the image. I don't know whether the bus appear as an inverted bus or enlarged bus. I don't know. So for that purpose we have to find the magnification. For that purpose we have to find the magnification. Magnification means image size by object size. Image is how much times larger than object. That is magnification. But here h and h dash are not available. The size of the bus, no, not given. H dash is also not available. We don't know. But we have another formula, minus v by u. Magnification can be found by using another formula, minus v by u. Minus v will be minus 15 by 30. V minus sign is there. V is 15 by 13 and u is what? U is minus 5. U I have already written minus 5. I don't want to explain all the simple calculations, that you can do it later. Minus minus cancels. Shall I discuss that? Minus minus cancel. 15 by 5. Can I do the division right now? 15 by 5 becomes 3. 3 by 30. Magnification is 3 by 13. I mean point something. Magnification 3 by 13. Its value will be 1 minute. 0.2 approximately. Magnification. Look at the sign of the magnification. You please note that I will write one property here. Please note, if magnification positive, it is erect image. You can write it as a note somewhere. Erect image. Erect image. Magnification negative means inverted image. You please write it somewhere. You please write it somewhere. Magnification positive means erect image. Magnification negative means inverted image. I got magnification positive, so I got erect image. Not inverted bus, it is erect. Erect image, smaller in size. Why smaller in size? Magnification is 0.2, that is the reason. 0.2, the image is 0.2 times object. The magnification less than 1 means that the image size is reduced, right? Image is 0.2 times object, means that image size is smaller. So erect image smaller in size, since V is positive number. V is positive means that the image in the right side. Image in the coating side. The image in the coating side. So if the image in the coating side, it will be virtual image. I have already discussed. Image in the right side, then it is said to be virtual. The image cannot be obtained in a white screen. So all the properties I found, okay, all the properties I found, the position I found, the inverted or erect I got, size I know, real or virtual, all the details I got. You please write down. If you don't understand, you can ask me, okay?
Sir, I cannot understand how you found the nature of the image.
Nature of the image I will explain once again. Listen. Those who have understood the solution, you may leave the class. Those who have any doubt, regarding the nature of the image, you please stay in the class. I am repeating. So who has asked doubt? Who has asked doubt?
Joshita, sir.
Joshita, listen. So magnification 3/13. That step is clear. Magnification 3/13. Is it okay?
Yes, sir.
Ah.
Yes, sir.
Yes.
Sir, but in the book it is given 0.23 as
0.23.
23.
Okay. 0.2 or 0.23. Both are approximately equal, right? 0.2 or 0.23. They are approximately equal. Here, is it correct? Then look here. So till magnification you don't have any doubt, right? Till magnification.
No doubt, sir.
Then listen. You have to memorize this one. You need to memorize this. Positive magnification. Erect image. You have to by heart it. Positive magnification, erect image. The negative magnification, inverted image. Please memorize this. I got positive magnification. Understood, Joshida?
Yes, sir. Understand.
Positive magnification, hence erect image. This part is clear to you?
Yes, sir.
Then why smaller in size? Because the magnification less than 1. Magnification less than 1 means smaller in size. Understood? Clear?
Yes, sir.
Magnification less than 1. Magnification, yes, smaller in size. Okay. Virtual image. Virtual image is due to the fact that the image in the right side. V is positive, image is in the right side. If the image in the right side, quoting side, it is virtual. Okay?
Yes, sir. Understood.
Okay then. Lina understood. Lina.